Okay, so where were we? Um, we've got a game that sort of works. Um, I think, and it's fine. There are a couple of things, a couple of directions we could go. Um, I'm sort of interested in how we might add some types to this kind of acceleration, velocity, distance calculations to make those, to see whether that makes sense. So, we might have um, a type for distance and a type for speed and a type for time. Um, that'll be one way. But I think what I'm going to do today is try to add some graphics to this. Eventually, maybe a little animation. But let's start with some SVG. So I'm going to import some SVG stuff. We probably want SVG. We probably want some rectangles and some circles. And a path. Attributes. And here we probably want width, height, view box, fill, X, Y, width, height. I think rectangles you have an RX and RY. And R. Can't find that module. Oh, I know. So we need to add the package here. Helm SVG. Let's see if that makes it a bit better. Okay. Now, the reason I've added those things explicitly, instead of doing dot dot here and importing everything, is that SVG and HTML share a bunch of attributes, and if I import them all, there will be clashes, and we'll have to specify full paths. We'll have to qualify some of the things we've already used. In the HTML, for example, I guess SVG has a text thing. We're not going to use it when we're drawing the graphics, but if I imported everything, then Ellen wouldn't know if this text here came from SVG or HTML. It would ask us to qualify that, and it makes things a bit uglier. So let's have a think. So let's just write a bit of our UI that is SVG, and let's call this graphics. And for now, we'll just return a div with an SVG in it of width, I don't know, 200. What syntax I'm using there? Height 200. And those are pixels. And view box, which is the sort of internal, the logical kind of space for that SVG. So that SVG, no matter what width and height it is, We'll start at 0, 0 and go up to 1,000 in its units. Compile that. Happy with that. And I suppose we call it graphics, didn't we? Graphics. We should now say nothing. I don't know how to set the background color on the SVG, so I think I'm just gonna draw a rectangle. I think this is x 0, y 0. Width 1,000, height 1,000. I don't know why I put these colons in. I guess I've been writing some Ruby today and my brain hasn't caught up. Oh, that looks good. Dude being a bit bigger. Room. It's a bit close to this field. How do we fix that? Maybe here. Add some margin to the div that it's in. There we go, that too. And now if we fill that grey. There we go. Let's put our space lander in there. That can be a circle. Let's put it at the center for now. I don't know. Oh. I was expecting that to be in the center here. Is it like that then? No. So I have my SVG docs here. CX, CY, okay. CX, CY. Can't find CX. Where did RX there? Let's compile that. There we go. I think that's in the center. If you make the radius a bit bigger, it will be obvious to see that. There we go. Yeah, I think so. So that's our lander. So So the first thing we could do is pass in the telemetry to this graphics and draw the circle at the right height. I wonder if it's a string. So that might be as easy as doing string from float telemetry dot height. Oh, it's going the wrong way. Ah, that's because coordinate system in SVG starts at the bottom left corner. Starts at the top right corner. So as we reduce this height, it gets closer to the top. Bottom right, I mean the top left. Couldn't have got that less correct, could I? So to convert that, we need to take you take 1,000 off it. Oh, it doesn't like that. So now we should start falling. Yeah. Excellent. So now what we want to do is, as time progresses, we want to move across here so we can draw a nice path of where we've been. And we could do that with just, we could do it like that, I think. And now that's looking quite good. Yeah. If I put 5 in. Eventually it's gonna. Oh, maybe we're okay actually. Yeah, I see it. And that was 25 steps, more or less. So maybe we just want to shorten that a little bit. We could do some stuff where the scale automatically adjusts. I just want to see this working to see whether it's a good idea or not. Right, so in order to draw this line of where it's been, we have to have some kind of history tucked away, right? So let's just make that work. So right now we just need the heights. So let's have history, and let's make that a list of floats. And initially we've got no history. Maybe we can just do that. Yeah. So now every time we're falling, we need to set the history equals history plus symmetry.height. So that will gradually build up. Cannot find a history. That feels the wrong way round. Let's just have a look. Cool. List. And now onto the front of the list. I think it really doesn't matter. And it really doesn't matter which around the history is stored. We could just cons that height onto the front of that list. In fact, let's just do that. we want to make a path from that history. So now I think with the SVG paths, we've got to construct something which is like move 50 something, draw a line to 30, 70, and so on. So let's see if we can turn those heights into a set of path things, right? So let's just format that for a second. Do you know what? It'd be much better if this went in the same order as we're going to draw it across. Whatever. I don't care. This dot reverse telemetry history. So the first one is going to be the first height we're at, the height we're at time 0. So we can index map, which I think takes a So I think index map, let's see what it takes. So it takes an integer and a b and return integer a and returns a b for any list a. So that's going to take an index and a height, and we want to return chords. Let's go to chords, and we're going to return time times 40. So now we've got our coordinates. We need to turn that into a path. So we're going to map over those heights. Let's just make it a non-awesome function here. Ugh, this is horrible. So we're going to use list fold. So we want to take a function that takes a thing that's in our list, which is that list of strings now, and a string returns so I think we've got a P in front of this. So I'm going to join them together. We want to start with move 0, 500. Let's just see what that does. Oh, we haven't got it yet. So 0. That looks pretty good to me. So we're folding it the wrong way. So let's try this. That's right. Oh. Let's put space there. I'm sure there's a better way to do this. Yeah. Actually, it's a hell of a line to confuse on my path. So that's looking as if it would give us the right path in SVG. So let's see. Path. I think that's right. It might be. So let's see what we need. D. Oh yeah. These are actually called path descriptors. Oh, exciting. Yep, we do. I'm probably seeing mine is going to parabola here. Yeah. Okay. Uh, what do I want to put on here? Telemetry. And put the current height on there. That's odd, isn't it? Doesn't seem to do it. Oh, I suppose it's a step behind, isn't it? Oh, that's wrong. So that's only moving at 1 pixel. In fact, what I want to do is move it 40 pixels, so I need to do that there. That's better. Look at that. Is this a good way to land on the moon? I don't know. So one thing the original game, the basic game had, is once you'd run out of fuel, it would just work its way to the end. So maybe we should add that now. Yeah, let's do that. So we need to recurse on this if the fuel is 0, basically. So we have another function here, which is very much like update, which does that. We'll call it, it's going to do more than 1 tick, so we'll call it run, and we'll say let new model. Hang on, let's actually write it down rather than something odd. And that's burn telemetry source let new model equal tick current burn tick burn telemetry get new model of falling. Alright, I'm going to say something like if fuel equals telemetry dot fuel equals 0 and run burn else. Free. So what that's going to do is it's going to tick for the burn. If we're still falling and the fuel is 0, we're going to tick for burn of 0 again. Oh. Just to get this working. So if I spend all my fuel to start with, so we don't show it when we crash. I was hoping to see a nice thing there. Um, um, well, let's pass our telemetry in here then. Yeah, that looks pretty good to me. This is all a bit messy, but maybe we'll tidy that up next time.